live captions. All right, so here we go. 4.1. And these are our vertical and horizontal shifts in which y'all, it's going to be like second nature. So I'm going to go to my whiteboard. Remember me giving you the parent graphs. I'm not going to print that out because I don't have it. I don't want to fool with my printer. So I'm just going to draw one. I told you to print these out for the 2 or 3 people that did it. X to the first, you've got a straight line. X to the second, you've got a parabola. X to the third, you've got the squiggle. X to the fourth, which is your even functions. X to the sixth, X to the seventh, the parabola starts to square off on the bottom versus a V-type bottom or a U-type bottom. Starts to square off. The higher the exponent with the even exponent is symmetrical around the y-axis because it's an even exponent. It's an even exponent, so it is symmetrical around the y-axis. X to the fifth, which is a continuation of the odd functions, it starts to square off like this as the exponent goes higher and higher. And this is an odd function, so it is symmetrical around the origin. Okay. You've got your square root function, which looks like that. You've got your 1 over x function, which looks like a half a volcano. And then you've got your 1 over x squared, which is your full volcano. And I gave you these earlier in the semester, and I will show you those right now. Right here, they're called parent graphs. They should be on here somewhere. Right there, parent graphs for the 1 or 2 that did print them out. And remember that vertical and horizontal shifts are compared to these graphs. So if I give you f of x is equal to 2 times x plus 3 quantity squared minus 1, then you know this is the horizontal shift. This is your vertical shift. And this is your orientation. And if the sign is positive, it's not there. That means it is irregular as the parent graph. So this is a cubic function. This is a squared function. So it belongs to the parabola that looks like that. And you're going to say, okay, it's a parabola, so it belongs to the parabola family. It's got a horizontal shift of 3 to the left. It's always the opposite, just like our vertex that we've been doing in completing the square. 3 to the left and down 1. So that's going to be 1, 1, 2, 3, and 1 down. This tells us that it's irregular, opens up, concave up, because it's positive. And this tells us it's going to be narrow. So it's going to look something like that. It's going to be a little bit narrower than the orange one. So that is a vertical and horizontal shift. Absolute value, absolute vodka. Forgot that one. All of these should be on that sheet that two of y'all printed. F of x is equal to absolute value of x. Looks like absolute value in vodka. It's a V. I'm not going to put the logarithms. We'll do the logarithms later. I'm not going to put them on here yet because we're not doing logarithms. So if I give you f of x is equal to -1 absolute value of x minus 2 plus 3, then you know, since you have the absolute value marks, that this is the absolute value. Your parent graph looks like that. So you've got a horizontal shift of 2 to the right and 3 up. The negative tells you it's opening downward. And the 1 tells you it's regular, it's not narrow or wide. So 2 to the right, 1, 2, 3 up, 1, 2, 3, and it opens down. And that's what this section is, vertical and horizontal shifts. And since you've been doing vertical and horizontal shifts with your complete the square, this should be like second nature. Should be real simple to you. Okay? Okay? So let's look at another one. Let's look at some of the questions that they're doing. Here's one right here. Now, remember, the number has to be attached to the x for it to be a horizontal shift. If the 3 is not attached to the x, it is a vertical shift. So in this case, there is no horizontal shift because there's no number attached to the x inside the absolute value marks. When I did that a while ago, the 2 is inside the absolute value marks. That's the horizontal shift. The 3 is outside the parentheses. The 1 is outside the parentheses. The 3 is outside the brackets. Anything outside the actual function is the vertical shift. Okay? So let's go back. And here's one right here. That's the horizontal shift. Because the 5 is actually attached inside the brackets to the x. So that's a horizontal shift of 5 to the right. I'm leaving that up there for a second just in case, because these are what your test question is going to look like. They're very simple, not a lot of math involved. Just, you know, you got your parent graphs with you. All you got to do is just compare it to the parent graph. The blue is the parent graph for absolute value. Then you just move it over for 5 places to the right and draw an exact replica because A is equal to 1. The number in front of the brackets is 1, so it's the same graph. Okay? Horizontal shifts are always the opposite. If you have a -h, you're going to move to the right. Write that down. If you have a +h, you're going to move to the left. But the h, or the number, has to be within the function. So it has to be within the parentheses of the function, or it has to be within the brackets of the function. Anything outside the brackets is your vertical shift. Anything outside the brackets is your vertical shift. Here's another example, square root. Here's the function, square root of x. That's your parent graph, which is in blue. And then you've got a vertical shift of -4. It's outside the function. And inside the function, you've got a horizontal shift of 3 to the left. So you're going to go 3 to the left and 4 down. And that is your red function. So how many test questions have we had so far? You've had 3. You've had this one and the 2 that I put on the whiteboard. Those are 3 test questions. Now remember, the way that you write this, the way that you write these equations is in standard form. F of x is equal to, I'm just going to make up an example, -3 times x plus 2 quantity squared minus 1. That's intercept form. The negative tells you if it's going the way the parent graph usually goes. If it's positive, it's the way the parent graph goes. If it's negative, it goes the opposite of the parent graph. So that's what the negative or the positive tells you in front of the A. That's A. 3 is A. So if A is negative, it's opposite. It's going in the opposite direction of the parent graph. If A is positive, it's going along the same lines as the parent graph. The 3 tells us the A, which is A. If A is between 0 and 1, meaning a proper fraction, then you have a wide parabola or a wide function or a wide graph. That means it is stretched along the x-axis and compressed along the y-axis. Think of a balloon and pushing down like this with the y-axis and stretching the balloon along the x-axis. It makes the balloon wide. If A is above 1, then you're going to have a skinny representation of the function because it's being stretched along the y-axis and it's being compressed along the x-axis. And that orange marker is going to the trash can. And I'm out of fluorescent orange, I believe. Okay, so if A is between 0 and 1, meaning a proper fraction, if A is between 0 and 1, meaning a proper fraction, it'll be wide. If it's above 1, meaning an improper fraction or a whole number, then it is a skinny parabola. All right? If the number is inside the function, inside the brackets, inside the radical, inside the parentheses, inside the whatever, if it's attached to the x inside the function, then you have a horizontal shift. Now, I would like to use blue, but every time I use blue, it looks like a different color. Not blue, I'll use this one. Horizontal shift. If it's positive, it's to the right. Negative, I'm sorry. If it's positive, it's to the left. If it's negative, it's to the right. This is about the only time that you're going to see positive mean left and negative mean right. And then the last one, we'll do it in yellow. If the number is outside the brackets, outside the radical, outside the parentheses, that is the vertical shift. And the vertical shift is normal, meaning that positive is up and negative is down. Now, the only thing you need for this part of the test is your parent graphs and that. That's it. There's not really much math that needs to be done. Parent graphs that two of you printed out and that. So, Miss Nagayan, what am I in Above the Waterfall? Am I a deputy that beats up hippies, or am I a peace-loving former Marine that grows pot on my grandfather's farm? Which one is it?
Your deputy.
A deputy? What do I do? Do I just beat up hippies or what?
You just go around busting drugs, like.
Oh, so I do a legitimate. So usually he makes me do crazy stuff in his other books. That's why I was wondering what I do in this one. In one book, which was made a movie, it's called World Made Straight. I'm a former Marine that wears a peace symbol that's a hippie that grows pot on my grandfather's farm. So he takes jabs at me when he puts me in the books. If some of you don't know, Ron Rash is a friend of mine, and he writes books, and he puts me in the books. And in, what's it called, Above the Waterfall? I'm a deputy, and evidently I'm an upright deputy that does what I'm supposed to.
The deputy.
And 1 foot. Was, what?
Les was a pretty crazy dude in Above the Waterfall. Had to read that for English last year.
So you saw my name in there?
Les was the deputy. I remember that. I have the book right in there actually.
Well, in the I think it's called Saints at the River, I'm a deputy that likes to beat up on protesters. And I beat up on protesters and I get in trouble because I beat up the protesters. So, and then another one, 1 Foot in Eden, I'm a sheriff that likes to arrest people just for not being around the town. In other words, people that come in town, I arrest them just for no reason. And is it Sella or Serena? I'm a campground and a mountain McClure, or McClure Mountain or something. So he puts me in those books. So if you see my name in there, that's my 15 minutes of fame. Anyway, Mr. Guyan asked me that question after class Tuesday. She asked me, "Are you in these books?" I said, "Yeah." I said, "But I do not know what I am in those books until students tell me, because I barely get a chance to read anymore." All right. So let's do another one. So let's do f of x is equal to I'm going to do an easy one for you. 3x minus 2 cubed plus 2. All right, I want you to sketch that with the parent graph. I want you to draw x and y axis. I want you to sketch the parent graph in there according to your parent graph sheet that you didn't print out. And then I want you to do the horizontal, vertical shift, and then I want you to study the 3 and tell me if it's going to be skinnier or if it's going to be wider than the actual function. Okay, and I'm going to have to make an announcement. Okay, Tri-County Tech is like dropping the hell out of students. Have y'all found that out yet? Okay, y'all are going to have to start telling me that y'all are in class when, you know, if I mark you absent 2 or 3 times, boom, you're gone. And then we have to go through the game of readmitting you into class. So I'm asking you, please, make sure you come to class at least 1 time a week so they can keep Tri-County off of you, because they're going to drop you. I really don't care if you miss a day or 2. But Tri-County, I don't know why they want to drop so many people. It just, I don't understand it. Has anybody been dropped yet? Not from this class, but from another class? Well, most of the ones I'm talking to here, y'all attend, so anyway, I'm just telling you. I just got an email from a student. I got an email saying I was dropped and my grandmother died and I have 5 dogs sick and 5 flat tires and whatever. All you got to do is show up for class. Just show up. Take the roll 1 time a week. That's all you got to do. All right, so what's the parent graph of a cubic function? Well, I'm going to take my handy dandy orange. There's my parent graph. So I'm going to take my orange marker, and my parent graph looks like that. I'm supposed to go through the origin, so I'm sorry. So I've got a horizontal shift. Well, I've got a positive right there. So positive means that it's the parent graph. It's going the same way as the parent graph. The 3, which I don't know what I colored it. I colored it orange. Well, I'll color it orange again. The 3 right now, I've colored a different color. Let's color it purple. The 3 tells me that I am being compressed along the x-axis. And I'm being stretched along the y-axis. So that means that the 3 means skinny. The horizontal shift, which is blue, means right 2 places. Or 2 units. And the vertical shift is +2 So that means up 2 places. Or 2 units. Whatever you want to call it. So my new graph, and I'll do my new graph in I'm running out of colors. I haven't used magenta, so let me use magenta.
Message coming in on secured channel.
This looks like pink, but it looks more magenta. So I've got if I compress this along the x-axis, it's going to kind of be skinnier and stretch it. So it's not going to be as drawn out. It's going to be, it's going to be skinnier. It's going to be skinnier. It's going to have a 2 to the right, 1, 2, and 3 up. 1, 2, 3. So there's my new origin. And I'm just going to circle it in blue. That's my vertical and horizontal shift. And my new one looks something like that. It's not supposed to go through the origin. Wherever it crosses, I'm not saying it's supposed to. This is the new origin right here. So it's going to be skinnier, and it's going to look like, and you can check on your graphing calculator. Clear y is equal to x cubed is your parent graph. And we'll color that black since it's going to be the basis parent graph. And I'll use magenta since we use magenta in the drawing. -3 parentheses x plus 2 let me try this again. X minus 2 parentheses raised to the second power plus 2. Second stat plot, turn it off. Now hit graph. And now I'm going to hit zoom fit. Zoom fit is 0. I'm going to zoom out. And that's not right. It's not supposed to be like that. The black one is correct. Something is wrong with the other one. So, oh, I put a square, dork. I suck. 3 and graph. There we go. It's not supposed to be negative either. Did I put in a negative? Good gosh, I'm just making up stuff. Sorry. There you go. And you see, it should have a vertical shift and a horizontal shift. We might not be able to see it because you need to zoom in. So zoom in. I'm going to zoom in right there. Okay, it's not picking up the vertical shift. Why is it picking up the vertical shift? Let me see if y is equal. I don't know why it's not picking up the vertical shift. Plus 2. Maybe I still haven't got it blown up enough. Yeah, because these are very small. So I'm going to zoom in one more time. And I'm going to zoom in right there. And I'm going to go up, do a trace. Yeah, there it is, 2. Y is equal to 2. So you just can't see it. And the original is at a y-intercept of 0, so you just can't see it. Let's see if I can zoom out one more time. See if I can show you that. Okay, there is the y-intercept for the black line, and you can see that this one is 2 up from that. So, you know, you can't see it there. You see it more in my sketch than you can with this because it's a very small y is equal. So we could change the window maybe. Change that to 1. I don't know if it will work or not. Do not use the keyboard, Hubert. I can't use the computer keyboard when I use the calculator. It's a pain. Oh, and it won't let me do that either. Okay. I got to hit enter. I'm just about ready to quit. All right. Negative, let's see, X-Men or X-Men. I don't know. -1 would be okay. And 10. And then Y-Men, we don't need -48. -10 would be good there. And maybe 70. And graph. And you see there's a little bit of a gap between the x-axis and the purple and the magenta. And this one is. And you see that this one is scrunched up, it's skinnier. The magenta line is skinnier than the black line. Not a real good one to see, but. All right, let's do another. Let's do one that you can actually see it. F of x is equal to the square root of x plus 2 minus 3. All right, sketch that one out and use the parent graph. So we've got a +1, got a +1, and the reason that green is positive, if nothing is there, it's assumed to be a +1. So nothing's in front of the brackets, or nothing's in front of the, or there is nothing in front of the radical, so it's assumed to be a +1. So that means it looks just like the parent graph. So I'm just going to draw a line here. Since +1 looks like parent graph as far as the orientation, it looks like the parent graph. We've got a horizontal shift of 2 to the left. And we've got a vertical shift of 3 down. Aren't y'all did complete the square? Y'all know this. So your parent graph looks like this. That's the square root graph, parent graph. And 2 to the left is going to be 1, 2. I'm exaggerating, making it larger. And then 3 down is going to be 1, 2, 3. So now our parent graph is going to be right here. Same graph, just starts at a different origin because of the -2 to the left and then 3 down. So I think I've given you 5 questions. There's 1. There's 2. There's 3. And I think we did 2 right here. So there's 5 test questions right there. And of course, it's worthless if you don't either have this memorized or have it beside you. Y'all settle down, please. And let's see. Now this type question right here, I want you to write it down. The reason I want you to write it down is because this is the difference between 110 and 109. 110, you're going to get more analytical problems, whereas in 109, you're going to get more business problems, more word problems. So this is a good test question right here. And of course, it is a quadratic with a horizontal shift of 55 to the right and 4,500 up. It's opening downward. So you've got a parabola that's going to give you a maximum at the vertex of 55 and 4,500. So if you sketched it, you would sketch it, the parabola opening downward at 55 and 4,500. And it would look like this right here. Here's the parent graph of -x squared. Let's see what else they got. This is orientation, talking about skinny, wide. Here's 1/2, it's going to be wider than the 2, which is going to be compressed. I've already shown you this. I've already shown you this. Odd functions are going to be around the y-axis, no, around the origin, and even functions are going to be around the y-axis. Here it is. So I'm going to leave that on the board. If you have an odd function or an even function, meaning x to the second, x to the fourth, x to the sixth, it's going to be an even function because it is symmetrical around the y-axis.
You have a work email.
If you have an odd function, excuse me, x to the third, x to the fourth, x to the seventh, it's going to be symmetrical about the origin. So if you do homework on this section, it's going to be a lot of sketching, a lot of matching it up to your, and looking to see where it's symmetrical. So you're going to need your parent graphs. You're going to need your horizontal, vertical shift, those sheets that I gave you. You're going to be able to see if it's symmetrical around the y-axis or if it's symmetrical around the origin. So we're not doing much math. Compared to completing the square, we're doing pretty much no math. This is just interpretation. Okay, well, this is pretty self-explanatory. The graph of an equation is symmetric with respect to the x-axis if for every point x, y on the graph, the point x negative y is also on the graph. So if you have a positive and negative y for each point, it's symmetrical around the x-axis. Okay? That's really not a test question, but the previous one, that's a test question. All right, let's look at this one. And yes, you're going to use your calculator because this is a x squared over x squared function. So it's going to look like somewhat of a volcano because of the x squared being in the denominator. So you're going to take your handy dandy calculator and you're going to graph 2x squared. So I'm going to graph y is equal, and I'm going to clear this one. And I'm going to clear this one. And just for giggles, I'm going to put 1 over x squared for the black graph. 1 divided by parentheses x squared, close parentheses. Oh, me. Hold on a second. There you go. Okay. And on here, I'm going to do 2x squared, parentheses, 2x squared, close parentheses, divided by, parentheses, x squared plus 1. Okay, and graph. Now, you see the black is, and I'm going to blow this up a little bit. The black is going up, looks like a volcano. That's the sketch. That's what a graph looks like when you sketch 2x squared. So you got some motion either going up or going down. Now I'm going to delete the first one now, just so now that you've seen it. And now we're just going to graph that one. And I thought it was going to be a little bit better than that. So I'm going to zoom in. I'm just going to try to get in the middle of this thing. I'm going to go right down here and enter. And you can see, since it's x squared over x squared, you still got the volcano look, only it's going kind of downward. And it's symmetrical around the x-axis. So it's an even function. If it was symmetrical, excuse me, I don't know why I yawn in this class in 111. I don't know why I do that. If it was in the first and the third quadrant, or the second and third quadrant, then it would be around the origin. But since it's around the y-axis, that's going to be an even function. Yes, y-axis symmetry. Okay. This one is going to be around the origin. And you can see it's around the origin. Plus the x cubed function. That's a circle. So it's symmetrical around the x and y axis. And that's basically 4.1. So what's the highlights of 4.1? Make sure you can sketch. Make sure you know about symmetry. And make sure you know the parent graphs. Okay? And we're going to cut it off today because y'all have still got work to do on your test. And I'm not going to load you down with too much extra new work. So we're going to stop right there. And if those of you, okay, now, those of you that's done what you're supposed to, and you've done your homework and you've got the test out of the way, then you can work on 4.1 homework tonight, okay, or over the weekend. All right, if you're still working on your test and the dog ate your homework and all that good stuff, then work on the test. Let me go ahead and take the roll. Stop the recording.